Good morning, dear friends. I am Dr. Rajin, Linus, Associate Professor and HOD of Electrical Engineering Department at Sanjay Godavat University, Kolhapur, Maharashtra. Under this electromagnetic theory series, we have understood how to convert Cartesian to spherical, spherical to Cartesian, and Cartesian to cylindrical, cylindrical to Cartesian. Initially, we studied the different variables r, x, y, z to r, theta, z, and x, y, z to r, y, theta. Like that, different vice versa also we have studied how to do mathematically. Today's lecture, we are going to learn about how one can convert entire Cartesian some problems related to tutorial problems related to Cartesian to cylindrical, cylindrical to Cartesian, then Cartesian to spherical, spherical to Cartesian, then cylindrical to spherical. How we can do in an as a primary stage, initial stage, how to do that in the easiest way. All those things we will learn. Let me share my screen now. I hope my screen is visible to you. So, for example, let me take one example how to convert one cylindrical to Cartesian. Cylindrical to Cartesian. In this cylindrical to Cartesian, we know cylindrical variables are R, phi, and z. Cylindrical variable, and Cartesian are x, y, and z. So we have example one variable R, phi, comma z. They have given one value, assume 3 pi by 3 and minus 4. That means R equal to 3, phi equal to pi by 3, z equal to minus 4. Then first we can summarize what are the formulas related to cylindrical to Cartesian. We know x is equal to r into cos phi, y is equal to r into sin phi, and z is equal to z, right? Since in cylindrical and Cartesian, z variable is z, so we can directly write z is equal to minus 4. But what about r and phi? R already given 3 and phi equal to pi by 3, therefore we can substitute directly in 3 into cos pi by 3. Cos 30 is equal to, we can write it as uh, 3 by 2 cos 30. You can use this triangular also for easiest way. 30 and 60 and 90. 1 is to root 3 is to 2. So we can write cos 30 equal to 3 in the root 3 by 2. That is nothing but 3 root 3 by 2. Then we can write it in another form. Then sin phi, r into sin phi can be, sorry, then there is a problem mistake. So we have 3 into cos 30, cos 60 degree, cos 60 degree can be written as 1 by 2, cos 60 degree 1 by 2, pi by 3 is nothing but 60, so 1 by 2, therefore 3 by 2. Then sin phi equal to 3 into sine of pi by 3 Sine pi by 3 we already, sine pi by 3 means sine 30, opposite side divided by hypotenuse. Therefore opposite side 3 in the opposite side is root 3. That 60 opposite side is root 3 divided by hypotenuse 2. Therefore 3 root 3 divided by 2. So we can write uh, x comma y comma z is nothing but 3 by 2, 3 root 3 by 2 and minus 4. 3 by 2, 3 root 3 by 2 and minus 4. So then we can take another one problem. How to convert Cartesian to cylindrical coordinate. Cartesian to cylindrical coordinate. In this Cartesian to cylindrical coordinate, x means Cartesian has given x, y, z. We have to convert that into r, phi and z. How to convert that? X is, it is x comma y comma z variables are minus 2, 2 comma 3. That means x is equal to minus 2, y is equal to 2, z is equal to 3. Therefore, we already know what is r. R is equal to square root of x square plus y square. You can refer the previous lectures also how we have derived that. Then tan phi is equal to y by x, which gives phi is equal to tan inverse of y by x. Then r, z already know both are z. Therefore directly we can write it as 3. So r is nothing but square root of x square minus 2 square plus 2 square. So we can write as root 16, root 16, root 4. 4 plus 4 root 8. We can write 2 root 2. Then cos sine, that is equal to phi is equal to tan inverse of y, already we know 2, and x we know minus 2. Tan inverse of minus 1 we can write 3 pi by 4. Then we can end up with this all variable. So we can write now x r comma phi comma z is nothing but 2 root 2, 3 pi by 4 and 3. So this is what we can do that. How to convert this both the cases. Then third problem is how to convert 2 root 2, 3 by, then how to convert spherical to Cartesian. Spherical to Cartesian. What is spherical to Cartesian? Spherical we know r, theta, comma, phi. And the Cartesian we know x, comma, y, comma, z. We have given they have given the variable r, phi and r, theta and phi is nothing but 8 pi by 4 pi by 6. So r is equal to 8 and theta equal to pi by 4 and phi is equal to pi by 6. Therefore, we can write it as what are the formulas related to Cartesian to spherical to Cartesian you should write. So we need x is equal to r into cos theta into sine phi, then y equal to r into sine theta into sine phi, then z equal to r into cos phi. So we can write r already we know 8 into cos of theta we know cos theta is cos pi by 4 into sine phi we know phi is pi by 6 sine pi by 6. So we can write that 8 cos, substitute all those values, we will get 2 root 2. Then r into sine phi 8 sine pi by 4 and sine pi by 6, that is equal to 2 root 2. Is that equal to r into cos pi 8 cos pi by 6 equal to 4 root 3. So we can write now x comma y comma z is nothing but 2 root 2, 2 root 2 and 4 root 3. This is what we have end up with. Then next fourth question. Fourth question is convert Cartesian to spherical. Convert Cartesian to spherical. That means Cartesian coordinate x comma y comma z. Spherical coordinate r comma theta comma phi. Spherical coordinate r theta and phi. Now Cartesian x comma y comma z variables are 2 root 3, 6 comma minus 4. So x is equal to 2 root 3, then y equal to 6, then z equal to minus 4. So from this we can write first what are the spherical coordinate wave equations. So we know the spherical coordinates are r is nothing but square root of x square plus y square plus z square. Then theta can be written as tan inverse of y by x. Then we can write pi is nothing but cos inverse of z by r. Cos inverse of z by r. So this is what we have studied already. So from this we can do this r is nothing but already we know xy is a square root of 2 root 3 square plus y is 6 square plus 4 6 square plus 4 square. So that is root of 64, that is equal to 8. Phi is equal to tan inverse of theta equal to tan inverse of what is y? Y is nothing but 6 divided by what is x? X is equal to 2 root 3. Therefore, we can write this is 3, 2, 3, then root 3, 3 cancel root 3. Therefore, tan inverse of root 3, that is equal to pi by 3. Then cos z is equal to square root cos inverse equal to z by r. Therefore, we can write uh, cos inverse of z is nothing but minus 4 divided by r is nothing but 8. Therefore, minus cos inverse of 1 by 2. Cos inverse of cos phi is equal to cos inverse of that. Therefore, from this cos inverse of minus 1 by 2. Minus 1 by 2, you can write it as 2 pi by 3. So with this, we can write r theta phi is equal to 8 pi by 3 and 2 pi by 3. 8 pi by 3 and 2 pi by 3. Then next final problem in this tutorial, if you want to convert directly from if you want to be convert fifth problem, uh, convert cylindrical to Cartesian, cylindrical to spherical coordinate. So cylindrical means r, phi and z. Spherical means r, theta and phi. So we are going to convert everything in cylindrical to spherical. So for that, either two ways. First, you convert cylindrical to Cartesian, then Cartesian to spherical. That is a one way. And second way, you first make the by using the conversion formulas and all, you make it everything in cylindrical to direct conversion of spherical, substitute all the formulas, all those things, and make the formula how to convert directly cylindrical to spherical. Then you can do that. I am going this procedure, first cylindrical to Cartesian, then Cartesian to cylindrical, so that you can easily understand how to convert cylindrical to Cartesian once again, similarly Cartesian to cylindrical. Let me first convert cylindrical to Cartesian. Cylindrical to Cartesian. Let me take first this variable, this r phi comma z is the values are 1 pi by 2 1. That means z equal to 1, phi equal to pi by 2, then r equal to 1. So let me do this now with this example. First, we are going to convert cylindrical to Cartesian. Cartesian. For that, x is equal to r into cos phi. Then y is equal to r into sin phi. Then z is equal to z. Therefore, that is equal to 1. There r into cos phi. R is nothing but 1 into cos phi by 2, that is equal to 0. Therefore, uh, total value will be 0. Then 1 into sin pi by 2, that is equal to 1. Sin pi by 2 is 1, therefore 1. So we can now write it as x, y, z can be write 1, 0, 1, comma 1. Then how we can convert this xy we said to this spherical. Let our next procedure is Cartesian to spherical coordinate. This Cartesian to spherical coordinate, we should know what is r. That means we are going to convert x, y, z to r theta comma phi. Therefore, r is nothing but square root of x square plus y square plus z square. Then theta equal to tan inverse of y by x. Then we have phi equal to cos inverse of r by cos inverse of R by Z, right? So cos inverse of Z by R. Cos inverse of Z by R. So now we can directly write this equation. Uh, how to do that? R is equal to square root of 1 square, 0 square plus 1 square plus 1 square. So therefore R is equal to root 2. Then theta equal to tan inverse of 1 by 0. Therefore tan inverse of infinity, that is nothing but pi by 2. Then phi is equal to cos inverse of z is equal to cos inverse of z is equal to 1 divided by r is equal to root 2, that is nothing but 45 degree. So we can write now r theta phi is nothing but root 2 pi by 2 comma uh, 45. So like that we can write, or otherwise we can write this way also, root 2 uh, 90 degree and 45 degree. So this way we can convert Cartesian to, I hope this tutorial will be helpful to you, and you can easily convert Cartesian to spherical and spherical to Cartesian, Cartesian to cylindrical, cylindrical to Cartesian, similarly spherical to Cartesian, and vice versa, all those things. Similarly, directly you can convert Cartesian as spherical to cylindrical, cylindrical to spherical. So just to do many problems related to that, so that you can practice yourself and improve the skills to do those all those uh, problems. So in this next class, we are going to learn about in the tutorial how to convert vectors. Can we convert vectors from Cartesian to spherical, spherical to Cartesian, or Cartesian to cylindrical, cylindrical to Cartesian? All those things we are going to learn. I hope this concepts are very clear and you can easily understandable. Those who have not subscribed this channel, kindly subscribe and press this bell button also, so that forthcoming lecture it will be reach immediately to your window. Wish you all the best. Thank you.